Question is find the sum of the series sec inverse root 2 plus sec inverse root 10 by 3 plus sec inverse root 50 by 7 like up to sec inverse of root of n square plus 1 into n square minus 2n plus 2 whole divided by n square minus n plus 1. It is in the square roots. Okay, I will explain this by two methods. First method, 1m means first method. I will draw the triangle. See, there is no direct formula for sec inverse. Always try to convert. If it is in the inverse and series, inverse function and series functions are there, then first try to convert in tan inverse x. Okay, this is the general term TR. So it is opposite by hypotenuse by adjacent. I will write sec inverse is equal to hypotenuse by adjacent. This term will be n square plus 1, n square minus 2n plus 2 we can write OPM, and this n square minus n plus 1 adjacent is or base. Okay, now PM square is equal to by Pythagoras theorem, PM square is equal to OP square minus OM square. Okay, I will write directly. OP square means I will remove this square root term, n square plus 1, n square minus 2n plus 2 minus this square. OM square is n square minus n plus 1 whole square. Okay, now it's simplified. First term I will simplify. This will become n to the power of 4 minus 2n cube plus 2n square. First you multiply by n square. Now by 1 means write the term as it is, plus n square minus 2n plus 2. Now here is minus is there, I will write for the second term a minus b plus c whole square. When it is in the form of a minus b plus c whole square, first a square n to the power of 4, second term square plus n square plus 1. If it is negative also, after squaring it becomes positive. Next minus 2 into n square into n minus 2n cube. Now 2 into minus 1 into 2 into n into 1 minus 2n plus, here is a plus, here plus 2n square. Okay, now I will simplify. See here, this n to the power of 4, this n to the power of will cancel. This 2n cube will cancel. This 2n square will cancel. 2n will cancel. Okay, this n square will cancel. Now only one term is here, 2 is remaining, here 1 is remaining. 2 minus 1 is 1. PM square is equal to 1. This implies that PM is equal to 1. See here, I will circle it because it is not given. We have found it. PM is equal to 1. Okay, now this can be written in the form of this general term sec inverse can be written as is equal to tan inverse of whatever sec inverse, it can be written as tan inverse of adjacent opposite by adjacent 1 by n square minus n plus 1. Okay, this is equal to sec inverse is equal to, I have written like this, or rather I will write sec inverse of something. This bracket term as it is, I will write tan inverse of 1 by n square minus n plus 1. We have already done it, again I will explain it. Okay, see here, always remember inverse, tan inverse of x minus tan inverse of y form it should come, is equal to tan inverse of x minus x plus y by x minus y by 1 plus xy. In this form it should come. Okay, in this form it should come. Okay, tan inverse of, see here, denominator I will take, first I will take separately denominator. dn means denominator, I will write in shortcut, denominator of n square minus n plus 1, it can be written as 1. It should come in the 1 plus xy form. 1 plus, if I take n common, then n minus will be remaining. So 1 plus xy form it came. Now numerator we have to adjust it. In the numerator here 1 is there. See here, numerator. See here, n plus n minus n minus 1 is equal to 1. We can write on these two. This the product of two terms is there. N into n minus 1. You take the difference. N minus is equal to 1. So numerator can be written as n minus in bracket n minus 1. Therefore tan inverse of 1 by n square minus n plus 1, it can be written as tan inverse of numerator 1 is equal to n minus 1. Denominator 1 plus n into n minus 1. This is denominator, numerator written is equal to tan inverse of n minus tan inverse of n minus 1. Okay. See here, summation means s is equal to, this is tr, I will take general term. S is equal to t1 plus t2 plus t3 up to tn. Up to tn we have to take. Okay. This formula I will box it. For t1, s is equal to t1. For n is equal to 1, this will be tan inverse 1 minus tan inverse n 1 minus 1 is 0. If as t1, you no need to write it. If t1 also, you can write also. If n is equal to 1, here, if n is equal to 1, tan inverse 1 minus tan inverse 0 plus. For 2, tan inverse 2 minus tan inverse 1. For n is equal to 3, tan inverse 3 minus tan inverse 2. For n is equal to 4, tan inverse 4 minus tan inverse 3. Likewise it will come up to, I will take tan inverse n. For n is equal to up to n, tan inverse n minus tan inverse n minus 1. See students, carefully observe here. This 2 will cancel, this 2 will cancel. Likewise, this will remain. The second of last second will remain, and the second here second will remain. If it is second will remain, then here last second will remain. If the first will remain, then the last will remain. I am highlighting by dotting it. Okay. Then s is equal to, tan inverse of n minus tan inverse of 0 is 0 only. I will not write. S is equal to tan inverse n. This is by first method. Okay. Now I will do this problem by second method. I will do the same the problem by second method. Second method. Let general term. This is the general term. Tn is equal to sec inverse of root of n square plus 1, n square minus 2n plus 2 whole divided by n square minus n plus 1. Okay. Now shift this sec inverse to LHS side. Sec of Tn is equal to whatever is the right as it is. Okay. Divided by n square minus n plus 1. Okay. Now squaring it. Same term is that I am not written. Square it. Second square of t to the power of n is equal to n square plus 1, n square minus 2n plus 2 whole divided by n square minus n plus 1. Okay, we know that 1 plus tan square theta is secant square theta. See here, secant square theta minus 1 is equal to tan square theta. We know it. formula is there. Secant square theta is minus 1 is equal to, now subtract 1 on both side. Secant square t to the power of n minus 1 is equal to n square plus 1, n square minus 2n plus 2 whole divided by n square minus n plus 1, here minus 1. Minus 1, minus 1. I am subtracting both sides by minus 1. Okay. Now secant square theta minus 1 is tan square Tn. Here also I will simplify. It. This will be n to the power of 4. Oh, sorry, this will become whole square. N to the power of 4 minus 2n cube. Already we solved it, again I will solve it. Plus 2n square plus n square minus 2n plus 2 minus, here if you multiply this, n square minus n plus 1 whole square whole divided by n square plus n square minus n plus 1 whole square. Okay, tan square of Tn is equal to, now n to the power of 4 minus 2n cube plus 2n square plus n square minus 2n plus 2 minus, if you expand it, n to the power of 4 plus n square plus 1 minus 2n cube plus, sorry, minus 2n plus 2n square whole divided by n square minus n plus 1 whole square is equal to, this will cancel this, 2n cube, 2n square, if you simplify it, n square minus 2n, 2 minus 1 divided by n square minus n plus 1 whole square, tan square of Tn. Okay, I will continue on the next page. Up to here I have solved it. Here it is tan square, take the square root. Tan of Tn is equal to 1 by n square minus n plus 1. Okay, now denominator, tan Tn is equal to, we can write to numerator 1 divided by 1 plus n into n minus 1. If you take common n, then this will be n minus 1. I have written 1 this side. See here, this numerator, difference of these two terms, n minus of n minus 1 is equal to 1. So Tn is equal to, I will shift again tan inverse this side, tan inverse of n minus 1 whole divided by 1 plus n minus 1 is equal to tan inverse of n minus tan inverse of n plus n minus 1. General term Tn is equal to, any method you can solve it. Okay, from here again summation will be there. S is equal to 1 plus 1 T1 plus T2 plus T3 up to Tn. Sum of all the term Tn for n is S is equal to, for n is equal to 0, n is equal to 1, tan inverse of 1 minus tan inverse of 0. For S is equal to 2, T2 means for S is equal to 2, tan inverse of 2 minus tan inverse of 0, tan inverse of 1. For 3, tan inverse of 3 minus tan inverse 2 up to for n, tan inverse of n minus tan inverse of n minus 1. We have already done it. I will cancel like this, this will cancel. Last S is equal to, the term remaining is tan inverse of n minus 0 is This will be the answer, tan inverse of n. By two method we can solve it, either by triangular method or we have to convert into tan theta. Sec we have to convert into tan theta. Okay, now we'll stop it.